Hi team, and welcome back. What we're going to do is we're going to have a quick look at solving equations and then graphing linear equations, and then that is the content that will be on your exam. So, solving equations, what I need you to note here is that this is where we work out what the number is that the pronumeral is representing. So when we have an x in an equation, when we solve the equation, it means we find out what number x is representing. How do we do this? Well, we have to get the pronumeral on its own, and we have to keep it positive. We have to undo the equation by the weakest operators first, by doing the opposite of them. What that means is that our order of operation, our BIDMAS, that shows us the strongest to the weakest operators. When we do solving equations, we're going to work the opposite way. We're going to work from the weakest to the strongest, and we're going to do them by doing the opposite. And remember, what you do to one side of the equation, you have to do to the other. So what does that look like? If I have a look here, I've got 15 divided by x equals -3. So 15 divided by x. The operator that I have at play here is divide. So I need to undo that division by, let's not go there. Let's start up here. I take that back. We'll get to there. So 4x. In between the 4 and the x, we always know that we have an invisible times sign. So I'm going to look at that and I'm going to go, right, 4 times x, that's the only operator at play. So I need to work out what the opposite of times is. So the opposite of times is divide. So 4 times x, I want to get x on its own and x to stay positive. So x is positive while it's on this side. So I'm going to remove or undo the 4 from the x. So the opposite of times 4 is going to be divide 4. And what I do to one side, I have to do to the other. So 4 times x times 4 and then divided by 4 again equals x. And 20 divided by 4 is 5. Let's have a look at number 2. X divided by 3. I have the operator that I have at this in this question is divide. So x divided by 3, x in this one is positive, so we don't need to move x, and it's not the one doing the dividing either. So the opposite of divide 3 is going to be times 3. And what you do to one side, you always do to the other. If I get x and I divide it by 3 and then I times it by 3, what I'm left with is x. And 3 times -6 is -18. Let's have a look at this one now. So 15 divided by x. These two questions are very similar, but they come with one major difference. Division, the direction of division is really important. So which one is the numerator and the denominator? In this one, x was the numerator, so it was the one that was being divided. In this situation, x is the one doing the dividing. So we have to undo the divide x before we can do anything else. And the only way to undo a divide x is to do the opposite. So the opposite of divide x is to times x. And what I do to one side, I have to do to the other. If I get 15 and I divide it by x and I times by x, divide x and times x are opposites, so they cancel each other out. I'm left with 15 on this side and -3 times x on this side. Now the goal is always to get the pronumeral or the unknown on its own. So at the moment I've still got a times, remember there's an invisible times there, times -3 attached to my x. So the only way to undo a times -3 is to divide by -3. And what you do to one side, you have to do to the other. Times -3 and divide -3 cancel out and we end up with x. 15 divided by -3 is -5. So x equals -5, which you can tell is true because 15 divided by -5 equals -3. All right, moving on to the adding and subtracting now. If I have x and I add 5 and it equals -3, I have to work out how to undo this add 5 from the x. The only way to undo the add 5 is to take 5. What you do to one side, you have to do the other. So -3, take away 5, plus 5 and then take 5. If I get something, can I add 5 and then take it away again? I'm back to where I started. So they cancel each other out because they're opposites. And -3 take 5 is negative 8. Negative 8, not negative 5. The next one that we have is 8 take away x. So in this one, we've got something a little bit different. X is actually a negative in this one. So we kind of want to move it so we make it positive. So in between here, we've got 8 take away x. How do I undo a take away x? Nice and simple, I'm going to add x. 8 take away x plus x equals, and what I do to one side, negative 3 plus x. These two cancel each other out, and we end up with 8 equals negative 3 plus x. Now I need to undo this negative 3 from my x. So the only way to undo a negative 3 is to do the opposite, and the opposite of negative 3 is positive 3. And what you do to one side, you have to do to the other. Negative 3 and positive 3 cancel each other out, and x is equal to positive 11. Last one-step equation that we're going to do here. So if I have x and it's got a power of 2, so it's x squared, the opposite of x squared has to be done to undo it, which is the square root. And the square root, what you do to one side, you have to do the other. And so x squared and then square rooted gives us an x, and the square root of 16 is 4. All right. The next one, these ones here were all one-step equations, and the reason they were one-step is because they only had one operator: multiplication, division, addition, subtraction, power. In this one, we have got 1, 2, 3 operators, which means we're going to have to undo this in 3 pieces. So if I read this question out loud and I say, x plus 4 divided by 6, add 2 equals 7. What's x? I have to undo this from the weakest bits first. So keep in mind that on top of that vinculum is invisible brackets. Brackets are super strong, which makes that the last thing we're going to solve. The next strongest operator here is the division. So that's going to be the second last thing we solve. And the last, or the weakest part, is the addition. So that's going to be the first thing we solve. That's one way of remembering how to do this. The other way is, if I read this out loud, what's the last thing I say? X plus 4 divided by 6 plus 2. The last thing I said was plus 2. So that's what I'm going to undo first. How do I undo a plus 2? I do the opposite. What I do to one side, I do to the other. 7 take away 2 is 5, plus 2 take 2 equals 0. And I'm left with x plus 4 divided by 6. Now the last thing I said was divide by 6. So the opposite of divide 6 is times 6. What I do to one side, I must do to the other. Divide 6 times 6, we're left with x plus 4. The last thing I said was plus 4, and the opposite of plus 4 is not 5, take 4. What you do to one side, you have to do to the other. Plus 4, take 4, x is equal to 26. One step at a time, the same process the whole way through, and it's not as tricky as it seems. That there is your solving equations recap. And the last one that we have here is graphing linear equations. So this is one of the very last topics that we covered in class before everything went a little bit pear-shaped. So what we're going to do is quickly have a look at this. Linear equations. All of the equations that we've looked at so far are linear equations. And if you remember, we talked about linear equations when we're graphing them, particularly having a y coordinate listed and an x coordinate. And if I show you my Cartesian plane down here, you should also recall that this is our y-axis and this is our x. So what we're going to do is we're going to sub values into our equation here. We're going to work out what the y equals, put those values into our table of values, and then we're going to graph it. So if this here is our equation or our rule, this is what's going to tell us what our y value should be for each one of these x values. So in the first one that we're going to work out, x is going to be equal -2. So when x is -2, I need to work out what y is. So I write down my equation. Y equals 2x take away 1. If x is negative 2, where that x is, instead of writing x on this line, I'm going to write down negative 2. So 2 times negative 2, and the reason I put a times in there is because between these two is an invisible times sign. 2 times negative 2, take away 1. 2 times negative 2 is negative 4. Take away 1. Y equals negative 5. So I'm going to grab this one here. This is my y coordinate for when x is negative 2, and I'm going to write down negative 5. In the next one, x is going to be 0. So when x is 0, what does y equal? I write down my equation again. And then, because I know x is 0 in this one, instead of writing x, I'm going to put in times 0, because x is 0. Take away 1. And 2 times 0 is 0. Take away 1 is negative 1. So when x is 0, y equals negative 1. And the last one we're going to do is x equals 2. So y equals 2x. Take away 1. That's our equation. Y equals 2 times 2. Take away 1. Y equals 4. Take away 1. Y is equal to 3. When x is 2, y is 3. So what this table of values actually shows us is our coordinates for this particular linear equation. So I haven't got any numbers on my Cartesian plane yet, but they won't be hard to work out. On my x-axis, I need to go as high as positive 2 and as low as negative 2. So I'm going to go negative 1, negative 2, positive 1, and positive 2. On my y-axis, I need to go as high as 5, as low as negative 5, and as high as 3. So I might go 1, 2, 3, 4, and 5. So negative 5, negative 4, negative 3, negative 2, and negative 1. And then I'm going to go up to 3. 1, 2, and 3. 1, 2, and 3. So to put these points down, we have to go across the x-axis to negative 2, and then up or down the x-axis to negative 5. So we're going to go across to negative 2 and down to negative 5. Because x is negative 2 and y is negative 5. In the next one, we're going to plot x is 0, so x is 0, and y is negative 1. So we're going to go down to negative 1. And in the last one, x is 2, and we're going to go up to 3, which should be about there. And if I'd done it with a ruler, it would have made a beautiful, straight, linear line. But we're just a little bit off because I didn't use my ruler, even though I had one. So there we go. And your linear equation goes on in each direction forever. So what we do is we actually put little arrows on the ends of them. All right, guys, I hope that helps you with your study, and good luck on your quiz. Bye.